Hey guys, just keeping in sort of like a Halloween type theme thing. This is the flyback driver. It's the Vladimir Mazilli. I'll show you the circuit. Now I've not used a 0.68 microfarad. I've used 0.27. The reason why I've done that is because my power supply plays up with it, and I'll show you in a minute. I've also used the IRF 260s instead of 250s. That's all I had, but everything else is what's supposed to be on there. I've done 6 plus 6 turns on my transformer. Yeah, so here it is the way I've done it, which is basically not very neat at all, but it does the job. It's just point to point wiring, 2 separate heat sinks. It doesn't get particularly hot because, as implied by the name, it's a zero voltage switching circuit. So when the voltage is at 0, it then switches over. So you're not going to have a lot of heat being generated there as it's doing that. Here's one of my capacitors. This is the second one that we can put on, so I can show you it. It draws a lot more current, and it sort of sends the display on here a bit doolally. I don't really want to break it. It's a 1 kilowatt power supply, so I don't really want to break it just for this. So I'm going to try not to. The other power supply there, it's just got a little bit of a cooling just going on to, because it gets warmest here. After a while, of course, when it all warms up, it gets quite warm on the front, but it's not too bad at all. I did used to use wires for these things, but I found that these using a bit of copper pipe, just a regular bit of plumber's pipe, you know, it will go up to your taps or whatever. I don't know what mil it is, but it works really good. It works really good. Normally with the wires, you can very easily knock them, bend them, and then you're messing around. And you've got wires with loads of little curves in, so it makes it a little bit more difficult. But anyway, so there we go. It's a bit of a Halloweeny type theme thing, because it's just generating high voltage. And to see this, what's going on here is you got your turns. You got a centre tap transformer, and as you can see there, so the grey and part of the brown there are at one side, and then the one turn of the brown there, and the rest in yellows at the other side. And you've got the middle of the centre tap, which is the brown and yellow coiled together there. Forget about this. This was just another way I was trying it. Just having 4 here and 4 here, and having the centre tap here. But I decided that I prefer it like this, just for the way I'm doing mine. And then inside here, of course, this is a flyback transformer. So this comes out the back of a TV, and it's got another side of the coil here, so we're not actually electrically connected to what's going on at this end. This is all being done magnetically or electromagnetically. So we're inducing a shifting AC current going in here. It turns on, turns off, turns on, turns off, really, really fast. And of course that induces in the other coil another current. But because there's a lot more turns on the secondary coil, just like with the solid state Tesla coil, you know, on that one I've got a couple of turns on the primary, and then there's a whole bunch of turns on the secondary. It generates a very high voltage, and that's what you get to see happening at this end. So let's turn it on. Now, I could do with 2 hands for this, but I'm just going to plug it in first. I'm going to find my big ass screwdriver. Okay, got my big ass screwdriver, and now I'm going to turn up the power. I didn't think about how to do this with only 2 hands. I need 3 just right at this minute in time, so let's just put some power through it first. So turn up 21 volts, just get it going manually by hand, and as you can see it will keep going out until I turn that up high enough that it sends my power supply a bit scatty. Oh. That's what it does to the power supply. I Don't know how long I can let it do that before it does any damage, but the overall effect of this, let me just shift that out of the way so it stops. It's pretty good. Now if I put on the other capacitor, it just sends my power supply over there. It's pretty scatty all the time, so I'm a little bit worried about it. But you can imagine when it's dark, naturally dark, and you're looking through your eyes, not through the lens of a camera, trying to compensate for the light. It's going to look pretty good. I wouldn't need to put to be honest with you, the cooling doesn't really do a great deal anyway, it's only on so slow. I'll just pull the plug on that. And even though it's going at 33 volts, it's only because it's got quite a wide jump there. Not quite sure how wide that is, but it's got to be close on nearly 2 centimeters. So it's got quite a bit of a jump to get through. So that's why it's on that voltage. But if you wanted to just run it at a lower voltage, just make sure it starts off with them closer together. And then going up the top, of course, it'll get a bit better as it warms up, as the pipes warm up as well. It'll help carry it up. That's what it's doing. That's effectively what it's doing. It's starting off down here, and as it heats, of course, heat rises, and it's going up the copper pipes, which are full of electrons. And as they get warmer, it sort of just makes it a little bit easier for it. So yeah, there we go. My attempt at the Vladimir Mazilli Zero Voltage Switching, ZVS circuit. Just on a bit of a Halloweeny theme, as we've got the Halloween weekend here in the UK. It's quite nice to watch. I quite like just looking at it. It's, especially when, like I say, when it's dark and I've got like the yellow lights on, like what's in that light, that lamp there. It's like a yellow bulb, so and it just makes the whole place look nice and soft. And, yeah. Anyway, thanks for watching, guys, and I'll speak to you in the next one. The next one's going to be quad related. Okay, quadcopter, multi-rotor, whatever you want to call them. What I did forget to do was connect up the other capacitor just to show you what it's like. So what I'm going to do is just going to pop that in the top there with them, so that it's 2 terminals connect with 2 screw heads there. Probably not the greatest of connections, but it'll still do the job. To be honest with you, I didn't bother screwing this one in here until I decided to try the second one, because that would just sit at the top. And the difference is, without the capacitors there, you've got a very feeble spark going across, very feeble. You put the capacitor in, there's a lot more current can be taken with it, and that's what you get to see there. This is just a secondary. I can actually get this going off this. Before on another one I had, I managed to mangle up this end so much that I thought on this one I'd leave this wire on in case I needed it. But so far so good, I have not needed it. So let's get this going again. It's this whole two-handed thing. I wonder if I can just put that in there so it's touching that. Just to put it in there like that, so it makes that gap a lot smaller when I first try and start this up. So I started off on 13 volts. Oh, I don't know if you see that then. It just cuts out. Oh, it's because the thing fell out the hole. So that's 13 volts. You don't really get a lot for 13 volts, do you? High pitch noise. Let's go up in voltage a bit. So it's quite hard to keep it going now, and that's on the same voltage as what we had it before. I'm actually going to go up a little bit higher. It's all like pushing this a little bit. This is with the second capacitor on. I'm just helping it by starting it at the bottom. Just because with that extra capacitor, it almost seems it's harder to get it to go. But that would be the recommended, because that's 2 in parallel of 0.33, so that's 0.66, give or take, and it says 0.68 to use. And then you can see the voltage over there now. So what it does do, it makes me worry sometimes when I see that. Doing that, I want to do it by itself now. Yeah, still has trouble. That's what it's like with the 2 capacitors. That's why I don't bother running it with 2 capacitors. I can use a lesser voltage. And the difference of it is, okay, there is a bit of a noticeable difference, but it's whether you've got the power supply that's going to be able to put up with that and not fail on you. And where it's just cheap enough to replace it. That's with the 2 capacitors. Personally, I'll run it with the 1. Just because it's easier. If I take that off again and see, look, don't quite get the zip every time at the bottom for it to start itself off. If I put that back in there, just try to turn it up slightly on the voltage, because it does say you can go up to 40 volts. I'll put it on to 36.2. Let's see if it do it for itself there. Okay. I've seen that go up to is about 8.3, 8.4 I think amps there. That's with the 2. Let me just cancel that bit of light. I'll just adjust the blinds a bit. It's a lovely sort of effect though, isn't it? And using the copper pipes, so you know, compared to using wires, it's a lot easier to find a bit of copper piping. This was scrap job I was on. Just chucking away a few bits of copper pipe, and I just grabbed hold of that. It was in 2 pieces. Sorry, in a single piece, and I cut it in half. So I asked them if I could have it. They said yeah. And there we go. Great fun to play around with. Absolutely no real practical use whatsoever. It sucks up current, as you can see, like, you know, in the 6, 7, 8 amps at 35 volts, 36 volts. It's but still fun. Still fun. That's going to go in the window later. Out in my bedroom, so as the kids are doing trick and treat later, trick or treat, they'll be able to go past this, because I'll never be able to hear them, because where I am in the building, I can never hear the front door as it's being knocked. But I can certainly leave that up in the front room window for them to see as they go past. Anyway, bye bye for now.